Hello, welcome back to 7-3, where we're talking about logarithmic functions. Okay, so in the previous videos, we talked about converting between exponential form and logarithmic form. And in one of the examples, I'll get to it right here. In this example, we said this is where we're headed. So we're going to do things like log base 3 of 81. This is saying 3 to what power, the x power, equals 81. And then we just use our head. We say, all right, well, like I know the powers of 3. 3 to the 4th power equals 81, so that means that x stood for 4. All right, so that's where we're going to be headed with these. And in this example, we call it evaluating logarithms by using mental math. So before I get started, I just want to mention this. In Schoology, there is a PDF called Math Facts, and it has the powers of 2, 3, 5, and 10. So we got the powers of 2, like 1, 2, 4, 8, 16, 32, etc. The powers of 3, which would have been useful for that problem, where you got 1, 3, 9, 27, 81, 243, etc. The powers of 5 and the powers of 10. So make sure you have that nearby so that you can, it will help with evaluating these. Another thing, and this is really where we want to be, another thing is learn them. Okay? Just learn what the powers of 2 are. It's not that hard, and you're going to be seeing them a lot. All you got to do is double it. Like 1, 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16, etc. The tens, of course you got that. The power tells you how many zeros you got. So 10 to the 4th power would be 10,000, which is a 1 with 4 zeros next, or behind it. You probably learned that a long time ago. Okay, so here's a couple of things that we've also brought up before that are also useful. So, if you have a logarithm base b of that same number, then the logarithm equals 1. And the reason why is because any number raised to the first power just equals that number. So that's very useful, okay? The other one is if you have a logarithm base b of 1, that equals 0. Because, and remember, the logarithm is the exponent. So this is just saying b to the exponent 0, b to the 0 power equals 1. b to the 0 power equals 1. And switching back and forth is something that you will get comfortable with. You will get good at it. So let me show you a couple of examples. And again, we're going to be using the powers that we know. And one more time, as I copy and steal these from the book does not use the parentheses. We're going to try to make sure that we use the parentheses because these are functions. And it actually sometimes causes problems if we don't. Right now it doesn't. And it's all based on the fact that math people are lazy. We're just lazy. But we should put the parentheses there. Okay. Let's do the first one. Log 1,000. Now, unlike this one and that one, this one does not have a base. So I have to bring that up. When you see log without a base, this is called the common logarithm. The common logarithm is always base 10. And the reason why is because that's our numbering system, base 10. And I brought this up a couple times when we talked about polynomials and when we talked about exponential functions. And a moment ago I said, make sure you know what the powers of 10 are. So for example, if I had, I'm not going to write it because I don't want to mess with this, but if I had the number like 532, that's 5 times 100, 3 times 10, and 2 times 1. Well, 100 is 10 to the 2nd power, 10 is 10 to the 1st power, and 1 is 10 to the 0 power. Those are the powers of 10. So our numbering system that we use is based on base 10. I guess that's redundant. So on the calculator, this is called the common logarithm. That's that one right there. So if you just see log, that means that you're using base 10. Move that a little bit so the reflection's not bad. And what this is asking, I'm going to do it on the calculator and double check. But what this is asking, this is what I'm going to think. This is mental math. If this is x, that's my exponent. So I'm thinking 10 to what power equals 1,000? And of course, you can do that. You don't need a list. You don't have to have this memorized. It's like 10 times 10 is 100, and 100 times 10 is 1,000. How many times did I multiply 10? 3. So I could do 10 to the third power equals 1,000. So log base 10 of 1,000 equals 3. Just like that. Now, before I put this away, and we'll pull out the calculator for this one too, but before I put this away, I just want to mention, this ln, that stands for natural logarithm, that's in chapter 7-6. That's not base 10, that's base E. You just said a letter. How's that possible? E is a universal constant, and it's very, very important. It's one of the 5 most important numbers you're ever going to learn. Actually, and I get to teach the 3 of them well, actually 2 of the last ones that are important. 1, 0, pi, I, which we learned about in chapter 5, and E. Those are the 5 most important numbers. What about the other ones? Can I do this one on the calculator, log base 4? You can, but there's no direct button for it. There's a way of getting around it, and that'll come up later. Okay, so let's do this one. This is what I'm thinking. So again, I'm writing what I'm thinking. 4 to what power equals 1/4? Now, 4 is not one of the numbers that we provided as a list that you need to think that you need to like know. That was 2, 3, 5, and 10. 4 shows up in the 2s if you skip every other one, I should say. Excuse me. But you don't even need that, okay? This we've talked about a lot. Any number to the -1 power is the reciprocal of that number. And we've seen this before. B to the -1 power equals 1 over B, as long as B is not 0, because you can't divide by 0, right? So this is just log base 4 of 1/4. The exponent, the logarithm is the exponent, is just -1. That's all that that's saying. Let's try this one. If I don't see the base of the logarithm, then that means that the base is 10. This is log base 10 of 0.00001. Okay? So what I'm going to think is 10 to what power equals 0.0000. I gotta count 1, 2, 3, 4. 1. All right. So I know you're not going to believe me, but this is so much easier if you think about fractions. It really is. So this is 10th, 100th, 1,000th, 10,000th, 100,000th. So you can also think of it this way. 1 over 100,000. Those are the same. Now, why is that easier? Because this tells me that I have the reciprocal of 100,000. Reciprocals show up when I get a negative exponent. Reciprocals of the numbers where I have a positive exponent. All right? This is 1 over 10 to the 5th power. So my exponent is going to be -5. And let's try that on the calculator. Common log 0.12341, and I got -5. So basically this is saying 10 to the negative fifth power equals 0.00001. Excuse me. All right, one more to do here. I'm going to think, because this is all mental math, 25 to what power equals 0.04. And again, I know you've been trained so much to not think about fractions, and that we hate fractions whenever we see them. But this is going to be so much easier if you actually do think of fractions, because it has to do with reciprocals. And reciprocals are easy to understand if I have fractions. 25 to the x power equals 1/25. This is 4 hundredths. So again, in my head, I've got 4 over 100, which reduces to 1 over 25. So what's the exponent I'm going to use here? 25 to what power equals 1 over 25? Well, just like I talked about up here, x equals -1. So log base 25 of 0.04 equals -1. All right, and like I said last time, I'll be doing more of these in the practice problems back where the homework is.